everyone, welcome back to my channel. In today's video, we will go dive into logistic regression. So before diving into logistic regression equations and with examples, as you can see here, so what is the linear logistic regression and what is the difference between linear regression and logistic regression? So both algorithms are supervised learning, but linear regression is a regression so with the class label is with the target or class label is a continuous value, but with the logistic regression, the class label or the target variable uh, is categorical. So logistic regression now is a supervised learning, but a classification, which is used to classify binary classification. So let's say, for instance, for the real linear regression, we have to, let's say, draw a line that fit our data. This is the blue line here. And it's only, let's say, it's a straight line. And in logistic regression, we will try to make a class for each table, let's say. And with the to make this shape here, we have to use sigmoid function. We will go for one example in the in the next. So assume this is let's say this is your data here, and you would like to draw a linear regression. You will try to draw, for instance, line from here, a straight line from here, and split this data, right? This could work, but in our case, we need a classification. So for the classification, we need to use a logistic regression. And as you can see here, the logistic regression is trying to draw this line because we use the sigmoid function. So through this lecture, we will see what is the how to, let's say, calculate the weights, how to use the data, how to calculate the weights, how to make the derivative, and this is also example, easy example with numeric stuff, and also I have also a Python. Let me just prepare it. Yeah, and this is the Python code that reflects the same example that I'm using in this document. So let's get started. So assume that, I mean, this I just try to make it as a graph, so it will be easy for you to follow. So for instance, let me just see, we have this data set here, which has two variables, hours studied and previous exam score. So for instance, if the student studied 2 hours and he get in the exam 60 and he will not pass, so this is the class label, as I said. It's categorized. It's not, let's say, a values between. It's not, let's say, predicting the score. If we would like to predict the score, so the score will be here. So we will use linear regression. If we need only one value, yeah or yes or no, or for instance pass or not, we will use this linear logistic regression. So assume that we have only these two variables, and I just replace it with x1 and x2, and each, this is with the gradient descent, and each variable will be connected to the weight 1, for instance, and this is weight 2. Sorry, this is the copy paste. Sometimes it's not okay, see. And this is weight 1 and weight 2, and this is weight 0. So now to get the prediction, we will try to use this formula here. Let me just zoom in, and this is the 0, 1 plus 0, w1 multiplied by the x1, and etc. Now after getting this result, we will try to use the sigmoid function, and after calculating the sigmoid function, we will try to calculate the cost, the cost, yeah, function. So we will say why we need this cost. So for instance, assume that you have predicted here 1, but this is not 1. It's the actual label is 0. So we have to update the weight, so until we get the let's see, the right value of the loss of the target. Now let's see. The goal is to build a logistic regression model that predict whether the student will pass or fail. So as you can see, the logistic regression is using this formula, this one here, which is called a sigmoid function, and this is it. We have seen it here in the diagram. And in the beginning, we will try to initialize the weight in all of these are zeros. So if you see, if we have 0 here and 0 here and 0 here, z will be zero value. I mean 0, right? And after that, we will try to use this sigmoid function. It will be 1, and this z, it will be minus 0. So all this formula here, it will be zero point 0.5. So let's have a look. I will just go back to come back to this, the derivative. But let's have one example. Let's see. For instance, the student one, it's 0, 0, 0. It will be, for instance, 0. This is 0 multiply 2, which is studied hours. You can see here. Let me just maybe copy this and put it down so we can see. So it's 2 multiply 0 and 60 multiply 0. It will be 0. And the sigmoid function will output 0.5. And we will do it for the second student. This one here, 3 and 75. It will be also 0. Because all these parameters are zeros, it will be the sigmoid function will be 0.5. And in here we need to calculate the gradient descent. So what the gradient descent is used to calculate. The idea here is to update the weights that we can get perfect. Let's see. Uh, Result. So for instance, we need to predict here 1 or 0, 1 or 0, and etc. And this is the functions that have been used for the gradient calculation. So by the way, this already explained in more details in the linear regression. So please do have a look in the video before. I will also attach it in the video description. So also, by the way, this talk much time for to prepare this. So please make sure to subscribe and like this video. And this is the derivative. Let's see, partial derivative of this equation here with respect to W0, and this is with respect W1 and W2. So by the end of this lecture, I will show you how the derivative was working. Let's see if you are interested. So just let me now continue with this, and we need to update. Let's say the weight for example for 0, and we will go here. This is the W0. It will be 1 divided by 4 because we have 4 students. And easy, let's see, equation. This is 0.5 minus 0. And you can see 0.5 minus 0 plus 0.5 minus 1. And let me just see this formula here. If our label, let's see, the actual label is 0, this one here. So this one will be, let's see, adding penalty to the weight. And if it's 1, this one will be 0, and this will be the adding the penalty to the weights. So that's why we have used for this is for the class 0, and this is for the class 1. And calculating the gradient, this is for the 0, this is for 1, and for 2. Now we need to update. The updating the parameters, we will use this formula here. So the old weight minus alpha, which alpha is learning rate, and this is the derivative with respect to, let's see, W0 and W1 and W2. And we will update this weights. Let's see. This is the first weight is 0. This is 0.05, 0.625. And we will try now to repeat what we have done in the previous steps. Say for instance here, and until we have, let's see, satisfied that our result is perfect. So as I said in the beginning, this already explained in the linear regression. So please have a look in there. So regarding the derivative here, so we have this, for instance, loss function, and we have this is the partial derivative with respect to w0, w1, and w2. How did we get this result? So if you are interesting, let me just show you this. It's a step by step, hopefully. Let me just see. Yes. So this is the loss function, right? And as you can see, this is the graph. So this is our loss function. The input to our loss function was a hypothesis, let's say the sigmoid function, and the output is y. And the input is z, and the output, let's see, is is a sigmoid function. And this is the input is I mean weights and input, and the output is z. So now we need to update this weights w1, w2, and w0. And please make sure that only we update the weights. The data here are fixed, so we don't need to update. I mean, it's not allowed to update the data. We only need to update the variables, the coefficient. Now we will start. If we would like to update this W1, we need to see where this W1 is used. Let's see, just for simplicity. So if you see, this W1 is used here, and because the result this used here, it will be also used here, right? Because it is also participate in the result, and also it will be used in the in the classification. Okay, and for the cost function. So now to get this weight, W1, that's the same mistake here. It should be W2. Not working. Sorry for this. Okay. Now, if we need to update this one, let's say for instance this is the the respect with respect to W1. So if you see in this formula here, we have a roll chain derivative. So because W1, as I said, it's participate on all of these, we have to get the derivative of each previous step until getting to this one here. So we have to take the derivative of sigmoid function with respect to g, then z with respect to h0 or sigmoid function, then z w1 with respect to z, and etc. This is the z. So as you can see here, the derivative of g, or let's say of cost function, with respect to w1, we will start from here. The cost function with respect to theta 0, or let's say sigmoid function, multiplied by the sigmoid function with respect to z, and here z with respect to w1. Okay, so let's just start with the first term here. Cost function, I mean g with respect to h0, h sigmoid function. So as you can see here, for instance, this is the g, and this is the formula, cost function, right? Now we need to drive this or derivative this with respect to h or sigmoid function. So where did we find h? It will be here, right? And one note, for instance, this is if you have a log, the derivative of log, it will be 1 divided by what is inside the log. It will be, this is for instance the log, and this is the derivative. And it's the same here, we have to see y multiplied, I mean y divided by what is the inside x, right? It's a sigmoid function, let's see. And we have removed this I because it's only, this is the general one, and after we have a summation, we will use the I. Then plus we will have this 1 minus y. This is the log, the derivative of log, it's 1 divided 1 minus h. This is for the respect with h. Now we need to derive the h0 with respect to z. So for instance, we have, this is the formula here. What is the derivative of this? The derivative of this, I mean, you can derive by yourself, or so this is the derivative of the sigmoid function. Oops, no. This is the sigmoid function, and this is the derivative of the sigmoid function. And as you can see here, h of x, it's equal this one here. And if we try to get the exponential to z, we will get this one here. It's only a simple multiplication. Multiply this by this, and one is equal. This, for instance, is equal 1, and you can see take the h outside, the exponential outside, and you can see you can get this. So it's hard, let's say, to explain this in a slide. It's need handwriting. If you are not, let's say, understanding this, please let me know, and I will try to write it. I mean, with handwriting, and of course step by step. And now, if we subtitle, for instance, this is easy. If we just replace this with this right hand, so it will be this one here, 1 minus h, and blah blah blah. And solving this equation, it will output this one here. So that's why we have the output is this one here. Now, regarding the z, so now we need the cost function, let's see, with respect to z. And with respect to z, it's this, we need this and this one, right? And this is the output. If you see, we multiplied this by this, and this one here, it's this is the result of this term, and this is the result of this term here. If we multiply it, we will have h of x minus y. Now we will go to the x0, I mean to w1. W1, it will have this term here. It's I mean the cost with respect to to h, then h with respect to z, and then z with respect to w1. And we will have this formula here. It's the output of the previous one. And z, so if you see, this is the formula. We need to drive with respect to w1. It will be only x1. And these terms, for instance, w0 and w2 are constant. It will be 0. So we will have only x1. So it will be x1, and we have this. It will be x1 half h of x, 1 multiplied by 1 minus half x. So that's why we have the formulas here. Where is this? Yeah, here. So I hope this is what will be clear to understand. And if you like this video, please subscribe and like this button. And if you have any question, just drop it in the comment below. I will answer it. Thanks for watching, and see you next time.